So let's get started with state variable analysis. So when I come to the state variable analysis, basically it means it's a physical representation of the system. Okay. But it regardless how the system got to that state, that means we are neglecting the initial conditions. If any inductor is there, like for example, you have a choke coil, there is an inductor. Okay, previously it was switching on. It takes some time to switch on, the tube light, the older tube lights, or your TV switch, right, which has a red color button. It takes some time to go off because there are certain initial charge, okay, which was previously charged. So here in this technique, we are not utilizing the initial systems. But apart from that, why it is very handy, it is applicable to realize in digital computer analysis. Now, here what we are going to learn is a state variable equation. Firstly, like your RLC network is there. So there are primarily two equations. One is your x dot is equal to ax plus bc, okay, and the another equation that you are having is y is equal to cx plus, okay. I have used z, so I'll be using this, okay, dz, where this z is nothing but the input and y is the output. So it is all in the matrix form, okay. This is the input matrix z, and y is your output, okay, output. And now here you will be seeing I have written this equation x dot. Although x dot is a matrix, same way A is the system matrix, okay, and B is the decoupled matrix. So here you will be seeing here I have already written these terms. The thing is that theory is not that important. The important is how you are able to solve the problems in the examination. So your matrix A, which is the system matrix, okay, and your B uh, has a matrix A has a dimension of n cross n. B has a dimension of n cross m, and overall state variable equation is put in this form. So here I have just mentioned out here. So we'll go to the next slide and we'll see. Okay. So here I have written. So we will be assuming zero initial conditions, and we will be getting the transfer function. Okay, for the state vector. So already I wrote this equation, right? X dot is equal to ax of t. Okay, plus bz of t. Just what you have to do, replace this t by s. Replace t by s. Just you have to use the Laplace of it. So when I'm doing differentiation, right, d by dt is represented by s. Okay, so this is basically x dot of t is nothing but x dot of t is d by dt of x of t. Okay, so this d by dt gets replaced by s, and t we have to substitute, so it becomes x of s, which I've written over here. Okay, so now I'll use a different color over here because it was same I've written already. So this is your s x of s, same way. Okay, a x of t replace x of s, b z of s. Now you have s x of s minus a x of s. You take x of s out. Okay, s minus a. Now we can multiply this system with an identity matrix I. The value of this is 1. Okay, so when I'm multiplying a into I, this gives me the result a only. That's why I've only written a over here. Neither I have not written a into I. But with respect to s into I is in, if it is a 2 cross 2 matrix, I value diagonal elements would be 0 and diagonal elements would be 1 and non-diagonal elements would be 0, 0. Now, if I want this s of value, I can write si minus a bz of s. Okay, so I can take this here, so it becomes an inverse of this and bz of s. So this is x of si minus a inverse. Now I already got this equation, x of s is equal to si minus a inverse bz of s. I had the complete equation as x dot of t was equal to a, right, ax of t plus b z of t, right, and I had the other equation y of t was equal to cx of t plus d z of t, right. I mentioned here everything I mentioned. Now we'll be going to the transfer function approach. So if you go back here, okay, so I mentioned here basically everything. That is not that important. The important is your problem solving technique, okay. So I have mentioned this z of t is the input vector, right. A and B dimensions are mentioned here. What are they? C and D, what are they? So everything has been mentioned in this particular thing. So nothing I have left. Hmm? So if you are going for this, so I will. Okay. So now let's go to the real part of it. The real part of it is that hmm, uh, we have to analyze these equations, okay, and we have to substitute here. And the one particular equation that matters to us is the final network function or the transfer function equation. So which we'll be getting by C. I mentioned here. A is the system matrix. Okay, dimensions are n cross n. B is the input conflict matrix, and this is output matrix, and this is the feed forward matrix. D. Everything has been mentioned. So here, once you get this equation number two, substitute this value of x of s here. Okay, back here in C x of s. So here I'm just substituting those. So C S I minus A inverse into B Z of s plus D Z of s. So y of s will be equal to z of s. I take common from here. C S I minus A inverse by B plus D. So output by input will give me the transfer function. So I'm left with this C S I minus A inverse B plus D. In most of the cases, D is equal to 0, right? But we will see in gate they are giving the D value also. We have to incorporate that D value also while solving the gate problem. So now let's go to the directly to the gate problem and let's see how do we solve. Okay, so if we have to understand it in a much better way, like suppose with networks also they ask. So basically, what I'm going to do, I'm going to follow these four steps. Step number one would be select the inductor current and capacitor voltage as state vector, or sorry, state variable, and then apply KVL and KCL. And when you apply KCL and KVL, you will be getting a first order differential equation, and then you can analyze that differential equation in the form of matrix. Let's suppose this is one question. It's not asked in gate, but find the state space representation to the circuit, determine the transfer function, where V of S, this is the input, right? And I of X is the output. So this is the output. So that means V of S by I of X will give us the transfer function, right? Output by input, right? This acts as y of s and I of x as acts as z of s here. So we need to get these values, right? So what did I told you? Current through the capacitor. So see, if I analyze the state vector, I know current through the capacitor IC is given as C dV by dt, right? So and voltage across the inductor is given as L di by dt, right? Now you see this current is entering here, it's getting divided into two parts. I would be equal to Ix plus Ic. Ix is moving through here, right? And the voltage across here is also V. So the voltage across the resistor will also be V. So this Ix would be equal to V by R, right? V by R. So suppose I substitute this value back there in this KCL equation. I is equal to Ix plus Ic. For Ic, I write the C dV by dt. Then I minus Ix, and Ix I found V by R, right? So d by dt is V dot, right? D by dt into V will become V dot, and V dot, this C I bring down here, so minus V by RC plus I by C, right? First equation I got in the differential form. Now what I want I dot. In order to get I dot, what I can do is same way, like I see VL is equal to LDI by dt. So from here you see, you get I dot, right? I dot is equal to VL by L. But is it only VL by L? Hmm? Let's see. You see this VC, VS, apply the voltage is getting divided in here, right? If you take this circuit, VS would be equal to VL plus, right? The voltage across the resistor, VR, right? If you notice, so Vs would be equal to the voltage across the resistor. So break down that. So Vs is equal to, and voltage across the resistor is nothing but it's in parallel with that voltage. So that is V. So that means your VL is equal to LDI by dt, Vs plus V. Keep LDI by dt this side. So Vs minus V, di by dt becomes I dot. Okay, this becomes I dot. So your I dot will be equal to Vs by L minus V by L. I write it ulta because I want to substitute for this V and L value first. That's the reason. Okay. So now I have my V dot as equal to, what was the value for V dot was equal to minus V by RC, correct? And plus I by C, right? Plus, say V dot, if you go back to the equation there, so from here also you can check C plus I by C. I could make out from that equation only because this is there, no? Plus I by C. Now your I dot value we saw, right? What is your I dot? I dot is minus VL by L plus Vs by L. So you have to put it in this form. X dot is equal to AX plus BZ and Y is equal to CX plus D. Okay. In this form, you have to put this equation. So now I put the equation V dot. So V dot I put here. If I'm putting V dot here, I'll write V by I. If I dot by V dot, then I'll write ulta I by V. So this confusion should not be there. Answer will be same. So V dot is equal to C. What are the values, coefficients of V there? Minus 1 by RC. So I write there. What are the coefficients of I there? 1 by C. So I write this coefficient of I. Again, what is the coefficient of V in I? V by L. What is the coefficient of I? There is no coefficient of I. So 0. Okay. Then your feed forward networks. Is there any coefficient of Vs there in V dot? No coefficient. 0. Is there any coefficient of Vs there? Yeah. There is Vs into 1 by L. That's what you will get Vs by L. So now you got this equation, right? Minus 1 by RC. So you got this equation. So from this equation, X dot is equal to AX plus BU. So you got the values, right? So you just substitute this. So that means this part becomes A. This is your A part. Okay. This is your B part, right? So you got A, you got B. So A is done and your B value is also B is equal to 0 and 1 by L, right? 1 by L. So the values are given there. Okay, for R, L, and C, the values are mentioned in the question. Those values you we substitute back. 1 by RC, what are the values given? Just check. Okay, the values are R is equal to 1. So this C is equal to 1 by 4 and L is equal to 1 by 2, right? L is equal to 1 by 2. Okay, because 1 by 4 is 0.25 and 1 by zero point 0.5 is 1 by 2. So you go back there and you will resubstitute these values. So 1 by RC, right? So C is your, okay. So 1 by RC minus 1 by RC. What, this is your A value. So you will get minus 1 by 4. This C is 1 by 4 now. So it will become minus 4. C is again 1 by 4, right? 1 divided by 1 by 4, it becomes 4. And L was half, so it becomes minus 2 and 0. So this is your A value. And the other value is your B value over here, right? But what do you want? You want the transfer function, right? You want the transfer function h of s that is equal to your y of s by z of s. In order to get that, we know that here d value is not mentioned, so it is 0. So that is given by the formula, right? C into si minus a inverse into b plus du. In most of the cases, this d value is not there. It is 0. So we just take this equation, right? But here one gate problem they have put. So Si minus A inverse, right? So S into I would be I is your this matrix 1 1 diagonal element 0 0. If you multiply it with S, so it becomes S 0 0 and S. Okay, so that's what I have done. So Si first I have to calculate Si minus A. Okay, minus A. So this value comes out to be 0 0 minus 4 of minus 4. So S plus 4 it will come. Okay. Then the second 0 minus 4. So minus 4. Then the third value 0 minus of minus 2. So 2. S minus 0. So S value will come. So you got Si. Okay. This is the value you got for Si minus A. Right. So I've got this. See, S4 minus 2 and S plus 4. This is the value, right? S4. Let's go back and just check. Yeah. S plus 4 minus 4, 2 and S. S plus 4 minus 4. S plus 4 minus 4, 2 and S. So this is your Si minus A. Now inverse of this you have to get. Inverse of A inverse is basically given by adjoint. Okay, adjoint of A divided by the determinant of A. But here it is very simple. You just calculate the determinant. Determinant cross multiply this. So when you are cross multiplying this and subtract this with this, so it will come as S plus 4 into S, right? Minus 2 into minus 4. So solve this S square plus 4S and this would be plus 8, right? So this is the determinant you got. Okay. Now, as far as this step is concerned, it's very simple for a 2 cross 2 matrix. Suppose you are having this A, B, C, D, right? So you are having the value this as A, B, C, D. For 2 cross 2 matrix, you just have to write this equation. For A inverse, you just have to write what I did, AD minus BC. Okay, just shift these values. Just put this D to A and D to A, and B you keep there minus B and minus. That's it. This is the shortcut for gate. Okay, so you do this value. Once you are doing this value, so you will get the result, right? So the result what you are going to get is, okay, I just shifted it. So the value was earlier, the value was s plus 4 here. So I shifted the s on top and s plus 4 here. So this is minus b. So it was minus 4, it became 4. It was 2, it became minus 2, right? So this is my value s 4 minus 2 s plus 4, and divided by the determinant, obviously. So this is my Si minus A inverse value, but the C value is still there, 1 and 0. Okay. So you notice C is 1 cross 2 matrix, right? And this is 2 cross 2 matrix. And this is, B is again, see, rows are, how many rows are there? 2 rows, 2 into 1. If the row, column and the row cancel, only those matrix we can multiply. So we will multiply this. We'll multiply this. So how do we multiply this? First element of this, okay, and the dimension would be same like this. Okay, it would be, again it will become 2 cross 1 like this. So it would be s into 0 plus 4 into 2. The first value will get, so s into 0 is 0. The first value comes as 8. Second is minus 2 into 0 and s plus 4 into 2. So it will become 2s plus 8, right? So I get this as 8, 2s plus 8. So I've solved up till here, right? Now I'm remaining with 1 comma 0, right? So this is 1 comma 0 is how many rows are there? Can you tell me? So we can see that it is having only one row and two columns, and this is your two rows and one column. Again, your row and this cancel, so 1 cross 1 will get remaining. So that would be 1 into 8, okay, plus 0 into 2s plus 8. So the top value will be 8, of course. And the determinant is down there, not to forget the determinant. So it would be 8s square plus 4s plus 8. So this value will come as 8s square plus 4s plus 8. So this is the answer how you got. But now let's analyze the gate problem, how they arise. See, consider the state space representation of an LTI system with matrices. This is asked in the gate for 2 marks. Okay. So the values here have been given. So the A value is 0, 1, minus 1 and 2. And now what do we want? I have written the complete problem. Just a second. Just here. Okay. Get can't. Okay. Okay. For the input, sine omega t, omega should be greater than 0. Okay, he's asking the value of omega for which the, okay, the steady state, the steady state output of of the system would be 0. System will be 0. Now, what he's asking in this question, if we carefully analyze this question, so he's asking you to calculate the steady state value of the system, and he has also given the value of d is equal to 1. So we know our formula, the primary formula that we'll be using here. Okay. Hello? Yeah, you can hear me? Yes. So the primary formula here is y of s by h of s, z of s, right? This is my transfer function. Directly I'll put. So this h of s would be, the equation is c, right? Into si minus a inverse into b plus dz, right? D value he has given, right? D is equal to 1. Hmm? Correct. So D value he has mentioned here, dz is equal to, right? So this input vector will be taking at this value, we directly will be taken as, so not dz, d. Z is not there, right? Just a sec. Let's rub this from here. D. That means other values are there. Just put here. C is how much? 3 minus 2, correct? And now first you have to calculate Si minus A inward. This is the complicated part. not complicated part. If you just multiply this, so this would be S 0 S and 0, right? This is your Si and minus of A, minus of this 0, 1 minus 1 and minus 2. If you just calculate this, so it would be S, right? S minus 0, and this is minus 1, and this is plus 1, S plus 2. And I told you the matrix inverse is simple determinant. That is your, see, matrix is what? A inverse would be equal to this. If this is your A, C, D, you just write AD minus BC, and you just interchange this D and A here. Write this as minus B and minus C. That's all you have to do. So first let's interchange it. Okay, then we calculate the determinant. So this would be S plus 2, correct, over here, and S over here, and minus 1 becomes 1, and this becomes minus 1, right? And the determinant is AD minus BC. So it is S square plus 2S, and minus of minus 1 will become 1 plus 1, correct? It becomes plus 1, right? It is plus 1. We got this step, right? We got the inverse part. Now we have C and B. What we need to multiply, we will be multiplying B because the dimensions we have to match. So the values there are, okay, so H of S value would be equal to, so the determinant we know is equal to C of S. This we have to yet to write. And the other determinant Si minus A inverse, Si minus A inverse we just calculated into B plus D is there, right? So C of S value here is, what is the value there? C of S value is, yeah, this is 3 minus 2. And this value we just found out, right? This value, when we just substituted this value, we got this as S plus 2. Just a sec. S plus 2, 1, minus 1 and S, right? I'll write this value. S plus 2, 1, S plus 2, 1, if I can do this inverse, it will come as S plus 2, that will become 1, and this will become minus 1, and that will become S. Yeah, S plus 2, okay, yeah, great. S plus 2, the original matrix was my, uh, here S, this is my S minus 0, very good, 0 minus 1 is 1, and 0 minus 1 plus 1, and S plus 2. तो ठीक है ना? तो but is it, what is the B value? Let me check the question. Mhm. B value is 0 and 1. B value has to be, okay, good. So the A value is, let's say 0. Yeah, here it is. A value is 0, 1, minus 1 and minus 0, 1, minus 1 and minus 2. So that would mean S minus A. That is S, and that value is 1, correct? So it becomes minus 1 and minus 1. Okay, down value also becomes minus 1 now. Here I have done mistake. So this is S minus 0 is 0, right? 0 minus 1 is minus 1, correct? Very good. Here down here it is minus 1, right? But what is the mistake? So 0 minus of minus 1 becomes 1, right? Then S minus of minus, it becomes 2, right? It becomes 2. So it is S plus 2, 1, minus 1 and S. Very good. So when I shift the S plus 2, okay. Oh, here. Okay, when I, then it is actually coming as S plus S, S, okay, good. S minus 1, 1 S plus, इसका इनवर्स लेना है ना हमको. अब इसका इनवर्स लेंगे तो ये वाला तो पार्ट ठीक है. फिर ये शिफ्ट किया ऊपर, S प्लस 2 किया, S को नीचे लाया, वेल डन. अब क्या करना है? अब जो ये माइनस 1 है, इसको वहीं पे रखना है, इसको प्लस कर देना है. 1 मेरा बन जाएगा माइनस 1, सही जो है. ठीक तो किया है यार, क्या कर रहा हूँ. ठीक है. तो ये ठीक है, s+2 1 -1 और s। 3,2 वो भी ठीक है। अब मेरे पास है 0 और 1, और ये d वाला वैल्यू भी है +1। ओके, सो ये वाला वैल्यू भी है। अब इसमें क्या करूंगा, मैं पहले इसको मल्टीप्लाई करूंगा, इसके s+2 ये है ना, ये है आपका 2 × 2, और ये इसमें कितने रोज हैं? 2 रो, कॉलम कितने हैं इसमें? 1। तो ये बन जाएगा 2 × 1 बराबर SI। तो ये आ गया आपका s+2 इंटू 0, ऊपर वाली वैल्यू +1 इंटू 1, और नीचे वाली -1 इंटू 0 +s। तो ये आ जाएगा आपका 1 और s, करेक्ट, 1 एंड s, और इधर है 3 - 2, 3 - 2, तो ये करो आप, और इसको मल्टीप्लाई इसके साथ करोगे तो आ जाएगा 3 और -2s, 3 - 2s। हम्म तो ये आपका बन गया 3 - 2, और ये बन गया 1/s, तो 3 - 2, और ये आ गया आपका 1 इंटू एस, 1, सॉरी 1/s। तो 3 को इससे 3, और -2 को इससे 3 - 2s, ये आ गया आपका 3 - 2s। बाद में आपने डिटर्मिनेंट आप पहले ही निकाल चुके हो, वो बोलना नहीं है डिटर्मिनेंट, वो जो पहले आपने निकाला है s² +2s +1। ठीक है, तो यह आ गया आपका 3 - 2s, सॉरी ये कहाँ गया मैं, हाँ, यह आ गया आपका यहाँ पर 3 - 2s, और पुराना जो डिटर्मिनेंट है जो आपने निकाला था s² +2s +1। अब ये क्वेश्चन +1 भी है, डी भी है, तो उसको इधर ले लो, 3 - 2s +s² +2s +1। तो 2s कट गया, तो ये s², 3 + 1 4 हो गया, +4, ये हो गया s² +2s +1। अब ये बोल रहा है कि कौन सी वैल्यू ओमेगा की, ठीक है, विच फॉर विच वैल्यू ऑफ ओमेगा इट विल बी ग्रेटर देन 0। तो इसको सिंपल तरीका है, इसको जो s को है ना, पुट s इज इक्वल टू जे ओमेगा, s इज इक्वल टू जे ओमेगा। तो इसका मतलब s² वुड बी इक्वल टू j² ओमेगा², एंड j² की वैल्यू क्या होती है? -1, तो s² वुड बी इक्वल टू -ओमेगा²। So here it will become -ओमेगा² +4. Down also it becomes -ओमेगा² +2s you are putting as j omega plus 1. Equate it to 0, right? You need the value of omega. You will get from the numerator. So the output will be 0, right? He's asking when the output would be 0, when the numerator would be 0, right? 0 by anything is 0. So you just equate this numerator. So -omega² +4 is equal to 0. So that means your -omega² would be equal to -4. This cancels. So omega would be equal to 2. So 2 radians per second. Okay. Now, one more question they have asked here. Okay. This is the question. Let me just check the question properly. Okay. Yeah. This is the same question they have asked. Consider a state variable of a system. Okay. x1 dot, x2 dot, 0, 1, minus alpha, minus 2 beta. Very good. So immediately whenever I look, this is for 2 marks. This is a juicy question for 2 marks, and I should not leave these questions. So immediately I come to know this is my A, correct, this is my B, this is my C, right. Now D value is not mentioned, so I can now here they have asked me to get the value of alpha, beta and omega. I know for second order system the equation is s² is equal to 2 alpha s plus omega m², correct, is equal to 0, where alpha is nothing but zeta into omega, right? This is the standard equation for the second order system. This would be s² plus 2 zeta omega n s plus omega n² is equal to 0. Now, do I need to calculate? Hmm? If I get this only one equation si minus a, will I get equation in this form? Let me just check. So if I do this si minus a, so this is 0, 0, s 0, 0 over here, and a value is here minus, so this is 0, this is 1, this is minus alpha, minus 2 beta, correct? Then s minus 0 remains s, 0 minus 1 will become -1, correct? -1. And then 0 minus this will become alpha, and s this will become s plus 2 beta, s plus 2 beta. If I just or get the determinant of this equation, so this will become s² plus 2 beta s minus of minus alpha the plus alpha is equal to 0. So straight away I come to know if I compare this equation, my omega n square happens to be equal to alpha. So therefore, omega n has to be root of alpha, right? So omega n is root of alpha here in this question, right? But I need to also check, see, root of alpha for omega n is mentioned here. That means omega n, this option is wrong. Only options that are correct are this and this, right? And now for zeta, definitely I will check for this also. So 2 beta s is equal to this. Just compare with the standard equation. 2 zeta omega n of s, and you will just calculate. So 2 uh, beta s is equal to 2 zeta omega n is root of alpha, right? Alpha into s cancels, correct? We need the value of zeta. So zeta value is equal to beta by alpha, root alpha. So this is the correct answer for this. So we'll stop this here. We just go through these similar type of questions are appearing in the exam also. Okay.